Hello, Professor McMath here, ready to introduce to you guys another exciting math video. Today we're going to be talking about operations on functions. So, our basic arithmetic operations, we have addition, subtraction, multiplication, and division. We can apply these rules with our functions. F plus g is adding the two functions f and g. F minus g is subtracting them. F times g and f divided by. Rather self-explanatory for these different operations. So we'll be given a function. F of x is x squared minus 4. G of x is 2x plus 1. And we're asked to essentially complete the four arithmetic operations. F plus g, g minus f, f times g, and f divided by g. So when we're adding our f plus g, we're just simply going to add the two functions together. Nothing too crazy about that. So we're going to go ahead and do x squared minus 4 plus 2x plus 1. So the key is to make sure we combine like terms. So when we combine the like terms, we'll get x squared plus 2x minus 3. And that's the value of f plus g. So when we're adding the two functions, the order is not going to matter because the order of addition does not matter. Whereas subtraction, it does matter. If we're doing g minus f, we need to make sure we do our g function first. 2x plus 1 minus, and we have to put our f function in parentheses. That we distribute the negative into the entire function correctly. Okay, so when we do that, we're going to get 2x plus 1 minus x squared plus 4, which will become a negative x squared plus 2x plus 5. Okay, so like I said, very straightforward. We're just going to simply subtract them in the proper order. F times g, we're now just simply multiplying the two functions together. X squared minus 4 times 2x plus 1. So we want to FOIL these two expressions. We'll get 2x cubed plus x squared minus 8x minus 4. Luckily, there's nothing to combine, so it's just written as that. And as far as dividing the two functions, well, we're just going to write them as x squared minus 4 divided by 2x plus 1. Now with division, we also need to include the fact that x cannot equal negative 1/2. Now where's that negative 1/2 is coming from? That negative 1/2 is coming from the idea that 2x plus 1, if that equals 0, we get negative 1/2. Now the reason why we're saying they can't equal negative 1/2 is because if we have 0 in the denominator of a fraction, that is not considered to be a defined value. It's undefined. So f divided by g will always be x squared minus 4 over 2x plus 1, as long as x is not equal to negative 1/2. So that's the idea behind your basic arithmetic operations, adding, subtracting, multiplying, and then dividing them. Do keep in mind with division, you need to include the idea of what value causes the denominator to be 0. So, same thing here, only now we have two different functions. F of x is x squared plus 5x minus 2, and g of x is 3x minus 2. So we're going to add the two functions together. X squared plus 5x minus 2 plus 3x minus 2 will give us x squared plus 8x minus 4. And then g minus f, well, then it's going to be 3x minus 2 minus the function x squared plus 5x minus 2. So when we work that out, we'll get the negative x squared. 3x minus 5x becomes a minus 2x. And negative 2 minus negative 2 becomes negative 2 plus 2, so that's 0. So just negative x squared minus 2x. F times g, again, we're going to FOIL that out. So it'll be x squared plus 5x minus 2. And then times 3x minus 2. So when that FOILs, we'll get 3x cubed minus 2x squared plus 15x squared minus 10x minus 6x and plus 4. So combining like terms tells us 3x cubed plus 13x squared minus 16x plus 4. So a little bit of work there, but nothing too crazy. Especially in comparison to our division, which we're just going to write as the top function x squared plus 5x minus 2 divided by the bottom function, then g, 3x minus 2. Where we need to include the idea that x cannot equal a positive 2/3. The value, if you set your denominator, 3x minus 2 equal to 0, and solve for x. That's where that's coming from. Okay, so that's your 4 basic arithmetic operations with functions. Just make sure you're careful with the order of subtraction, watch out for negatives, all that kind of stuff. The second idea to talk about is the composition of a function. This might be a little new. So the composition is going to be written as something like this. We have notation of f of g of x, using the results of one function to evaluate a second. We've written like this, the first one, in parentheses, or you'll kind of see it written with like an O in between them. Just simply a dot between f and g implies multiplication, but if it's an O, it's a composition. So what we do is, similar to how you would find, like, if f of x, we'll say, is x squared minus x plus 1, if they want you to do f of 1, you plug in 1 for x, and you evaluate. But if they want you to do, like, f of 3y, well, then you plug in 3y in for x, and evaluate that. So the composition is, instead of saying f of 3y, we'll say f of g. So then you're going to replace the x in the f function with the entire function g of x. Now it looks something like this. So for both of these, we want to find f of g and then g of f. So we'll do f of g on the left side, g of f on the right. So for f of g, they want us to replace the x in our f function with the g function. So since we're squaring x and f, we'll do square whatever the g function is, which is x minus 6. So when we square that out, which we need to make sure we write it twice so we FOIL correctly, we get x squared minus 6x plus 36, and then the plus 2 at the end, which will give us x squared minus 12x plus 38. That'll be f of g. G of f is the same idea, only now it's the other way around. Now we're going to take the f function and plug it in for x in the g function. Well, there's a single x term in g. It's just x. So we're replacing x now with x squared plus 2. Well, that's easy. That's just going to be x squared minus 4 for our final answer. So f of g, g of f, that's all we are looking for these particular types of problems. So if we have these two functions now, f is 3x squared minus x plus 4, g is 2x minus 1. We want to find f of g and g of f. Well, f of g, we replace the x in the f function with the g function, so it'll be 3 times 2x minus 1 squared minus 2x minus 1 plus 4. So when we FOIL out the 2x minus 1, you're going to get 4x squared minus 4x plus 1. And then when we distribute the 3 and then the negative into our parentheses, we'll get 12x squared minus 12x plus 3 minus 2x plus 1 plus 4. So this will yield us 12x squared minus 14x plus 8. And there's the value of f of g. G of f, same idea. So we're going to replace the x in the g function now with the f function. So it'll be 2 times 3x squared minus x plus 4 minus 1. So this will give us 6x squared minus 2x plus 8 minus 1, which will give us just simply 6x squared minus 2x plus 7. And there's g of f. That's what we're looking for with our composition functions. It's generally a very straightforward idea behind finding this. Nothing too crazy, nothing too complex. Finally, a question you might be seeing similar to for the SAT or ACT type tests. You might be asked to find f of g of negative 2. Well, the key to doing this is finding g of negative 2 first. That'd be negative 2 squared minus 7 times negative 2 plus 1. 4 plus 14 plus 1 equals 19. Now, since they want f of g of negative 2, now we need to find f of 19. So it'll be 3 times 19 minus 5, 57 minus 5, 52. Okay. So that's the idea behind evaluating a composition. You just work inside out. G of -2 yields 19. So then that's saying this then becomes f of 19. And then we plug the 19 in for x for f and then solve that out. Alright, so that's all we have the video for operations on functions. So I will see you next time. So, McMath out.